Now we'll look into uses of an AP. So AP as a topic comes from sequence, right? It's a branch of sequence. Sequence are nothing but set of numbers which is in a particular order obeying particular rule. So we can see patterns over there. So when we talk about rules and patterns, we certainly can express it mathematically as an expression or an equation, which in turn can be programmed, right? And which in turn can be used to predict. So where do we see such a thing happening? We see in our current topic, machine learning and artificial intelligence, which is the new upcoming topic, right? Now, I want to talk about not AP, but other things that comes under sequence, so that you appreciate that yes, we are learning a topic which is part of sequence, and sequence has a lot of things, lot of branches under it, which helps us to understand a lot of things. Okay, so one of the famous sequences is Fibonacci sequence. So this sequence, the rule is this: start with 0 and 1, add 0 plus 1, 1 plus 1, 2, 2 plus 1, 3. That is, add the last two numbers that is there in the sequence, 5. So when you add them, whatever number you get, you fill it in the space. 8, then we have 13, then we have 21, then we have 34, then we have 55. So such are your numbers. So this will continue till end of time. So where do we see them? We see them in arrangement of leaves. I mean, literally. It's kind of weird, but yes, it's true. The branches, right? The how tree branches it out itself. Even there you see such numbers. Flowers, the petals in flowers, seeds. Just web search sunflower plus Fibonacci sequence. You can pause it now and do that. Just go to this. You'll see pattern, such pattern. Okay. So you might just see a figure and you'll see something like this. How is that you're able to produce this from this particular set of numbers? We'll be seeing that. So then web search all these flowers. If you count the petals in them, right, it will be in the sequence of 3, 5, 8, 13, and 21. Right, you can observe storm and cyclone, which has this particular structure obeying this particular sequence. Right, seashell and storm, they have the similar structure. So if you happen to have in your biology class, or if you happen to have seashell, so if it's cut open, right, or if you happen to get a seashell, or if you have a seashell, if you I don't think it's easy to cut open on particularly in a particular axis. You can break it open but not cut it through, right? It has to be done by someone, I guess. I've not done it actually, but yeah, we can always web search it and have a look at it. So this is the pattern we see in the seashell as well. So how is this particular sequence able to generate this particular structure? To understand that, of course, we'll make use of our code. I've generated here. Okay, I'm not generated, but sorry, not there. Oh, okay. Okay, it's over here. So Fibonacci sequence, yeah, spiral, sequence and spiral. Right. So here I'm generating a the unique pattern that is generated by Fibonacci sequence. How? See, depending on this numbers, I'll draw squares with this particular length as the side. So 0 means a dot. I need to draw a square with whose side is of length 1, and one more square, and a square of side of length 2, a square of side length 3, a square of side length 5, and of square of side length 8. Okay, I'm not doing a good job. So let me do it with help of the program. So I want to generate around 10. You guys can generate different values. So I'll show you how. But yeah, you can do this. I have to show you this. Yes. Can you see that? That is your squares being generated with the help of Fibonacci sequence. Right? This will go on. I just gave 10 squares, so it will end up now. So here I'm going to copy this and I'll show you how is that this particular structure can be generated from this particular thing. Okay, so we'll do that. So start with the innermost square. That is the starting point. It's somewhere over there. So here draw a quarter circle. That is from as a place of a diagonal, you draw a quarter circle. Don't worry, you'll understand. So if I do that, right? Can you see that? So can you see a pattern? I'm not doing a good job of drawing. You guys can take a printout and do it yourself and post it on the website or Instagram handle. You guys can post it over there. So do a better job than me. I'm not doing a good job. Let me use this. Uh, Better. Can you see? I mean, it's not very clear, but yeah, my diagram is not that good. But can you see the pattern? It's almost similar, right? The cyclone, it also looks like that if you zoom out and satellite view. This is how it looks, right? So, I mean, you guys web search and you'll find a lot of things that is related to Fibonacci sequence. I just showed you one, right? It's left to your interest, and I hope, I mean, I would have been interested if I was in your place. I would have surely done the research, right? So now, because of net, you guys have a lot of access to knowledge, and which can't be done in schools or which can't be just taught over there. So you can learn on your own a lot of things. Please do that. It's fun. I mean, it's fun for me. I hope it is so for many of you. And it's okay if it's not fun. Maybe with age, you'll find that topic which is interesting and you'll do your research over there. Right? Now, moving on. Honeycomb. Even this, right? They follow a particular pattern. So honeycomb, there's a particular reason why the honeycomb is structured like that. It occupies the least possible, it has the least possible perimeter and the highest possible area occupancy. Okay. So you're given a space, if you want to make best use of the space, have a honeycomb structure. Right? You can see this. So even this is a particular set of pattern and behavior of bees. Even it seems bees can count up to 3 numbers. I mean, again, all this is something which I read somewhere from a published paper. So of course, things can always change. They can come up with some other observation, but yeah, as of now, that's what I read. So there's a pattern to which they behave also, like particular flower they go to and so on and so forth. So there are a lot of research in pattern recognition and things. It is a huge field. AP is a small topic over here, but the implications, the things that is related to its relatives, they're very powerful, and it's been used like in places we can't even imagine. So waves, you have your sound waves, right? Even this can be there are patterns associated with waves, music, even foam, right? The bubbles which comes out. Even there, this I'm not very sure of, like, but yes, this is one of the things that also has patterns. I think it's related to even Fibonacci sequence as well. So even waves, let me draw it. Okay, let me use some other color. I won't be doing a good job, but right. So even this obeys Fibonacci sequence. Again, I'm not doing a good job, but yeah. All this you can web search and you'll find out all the patterns that is associated with all of this topic. So there is one particular question which deals with Fibonacci sequence generated spiral. You find the length in one of the questions. So you do that, but yes, AP is an introduction to the topic of sequence, and sequence is pretty much used everywhere. That is the future. So that's why an introduction in topic to sequence, that is AP, is an important introduction. It's not too hard, but yes, I want you guys to understand the importance of what you're learning.